welcome back. Since the beginning of time, men have had a passion for building things, structures, objects. Now, in the most recent history, objects and structures were either done on paper or on the computer. The problem with orthographic projection is that not all surfaces appear in true measurement. How do we solve that? Well, we use descriptive geometry. Descriptive geometry is being able to manipulate picture planes in a multi-view drawing and creating true length objects that were once foreshortened surfaces. Now, to get started, there are some rules that you have to go by
to fully understand descriptive geometry. First, let's find out what orthographic projection is. What is that? Well, if we have a 3D object, we are placing it into a 2D form in the form of a multi-view drawing. In the second quadrant, we are represented as the top view. In the third quadrant is the frontal view, and in the fourth quadrant is the right profile view. To get the true size and shape of surfaces, we need to know two things. First, we need to find an edge view of the surface. Next, we need to have a true length line segment from that edge view. Now, how do we do that? Well, there are two rules we need to follow. First, in one view, if a line segment is parallel to an auxiliary view, then in the corresponding view it will appear in true length. Also, if a true length line segment is perpendicular to an auxiliary view, then in the corresponding view it will appear as an edge view. Now, that might sound complicated. Here's an example. If we take a look at our object in our multi-view drawing, let's use line segment CD as our example. First, we know that it is parallel to this auxiliary view, which means is that it's in true length in this corresponding view. Also, CD is perpendicular to that auxiliary view, which makes it an edge view in that corresponding view. So, I hope that helps a little. So without further ado, let's try to find the true size and shape of surface FEHG. If we look at our drawing, in the top view, that surface is represented in the color orange. Now, we are lucky in this drawing that all of the views have an edge view in all of them. So, the edge view for that surface is highlighted there. So now, all we have to do is create an auxiliary view parallel to that line segment. Next, we take projector lines which are perpendicular to the auxiliary view and which cross those points. Next, we need to strike a mark to create our new points E and F. How we do that is we go to the view preceding the view, and point F, the distance is perpendicular to the y-axis, and point E's distance is to the y-axis as well. Coincide, that is how we find points H and points G. Now it's just a matter of connecting the intersected points in which we receive our true size and shape of surface FEHG. Well, since the first one was so much fun, let's try to find another true size and shape of a surface. Surface BFDH is the color gray surface, and now we need to find the edge view, which is in our frontal view. Now we just have to make a auxiliary view parallel to that edge. Again, we are now going to make a projector lines that are perpendicular and strike at those points. Just like our first surface, we are striking points that are at the new auxiliary view. Now this one's different. We can either go by the right profile or the top view. Both views will give us the same distance for our true size and shape of our surface BFDH. Now we just find our striked views for points D and H, and it is just a matter of marking those points to get our true size and shape of BFDH. Well, we got 2 down, 2 more foreshortened surfaces left, so let's find the rest of them. What I'd like you to do is hit pause. See if you can find the true size and shape of the surfaces we haven't found using the methods that we used to define our 2 true size and shape surfaces. If you got them, great. If you haven't, here's what we came up with. We have surface EAGC, which we have a auxiliary view parallel to its edge, and that's how we get the true size and shape for that one. If we go to surface ABCD, we find that it is a mirror image of FEHG. So it's just a matter of transferring views and making the mirror image the same. You're probably asking yourself, why didn't we do EFAB or CDGH? Well, they're already true size and shape before we started.
Well, once we find the true size and shape of our surfaces, we get this object. Now granted, there are much more complicated structures that you can use descriptive geometry. For example, at Northern Michigan University, we have the Superior Dome, one of the world's largest wooden dome structures, and it couldn't have been possible without the use of descriptive geometry. If you haven't seen it, you should check it out. Until next time.
Oh great, there goes my security deposit.